All right, so let's do another one of these kind of like solvey thingies. We got some hints about tangent. I want to figure out what sine of theta over 2 is. So I'm going to grab my identity right off my paper. I've got it on my other screen over here. So I know that the sine of theta over 2 equals the square root of 1 minus cosine theta over 2. Now, I need to decide whether or not this should be positive or negative. I'm going to deal with that right away before I forget about it. Now, they told me what theta was, but that's not helpful because I want to know where theta over 2 is. Now, but they only told me theta. Ooh, I know how I could fix this. I could figure out where theta over 2 is by dividing everything there by 2. I get pi over 2 is less than theta over 2, which is less than 3 pi over 4. Okay, shoot, where are those things? Let's see, pi over 2, that's right here. 3 pi over 4, that's over here. So theta over 2 is somewhere in that region. Well, in that region, in quadrant 2, that region seems to be sitting in quadrant 2. Well, then there, cosine is positive. Look. So I want to choose the positive case for this one. Note that if I hadn't done that, I would have jumped down into quadrant 3, where sine is negative. That'd be bad news bears. I want the positive case because pi and 3 pi over 2 is in quadrant 3. Now that we got that, we need to do some business to figure out, okay, well, what's the cosine of theta going to be? And they just gave us tangent. So I don't have a good identity that converts tangent to cosine. So we could go Pythagorean here in order to figure out what's going on, but I don't have a good one for tangent to cosine. I can turn tangent into secant, no problem. And then I could do some flip around, but at that point, why are we even bothering? Let's just do this method. So theta is in quadrant 3. Note that we're using theta now because we've got the cosine of theta right there. So I want to be in quadrant 3. Tangent of that theta is opposite over adjacent. So we've got 12 and 5. These better both be negative because we're in quadrant 3. And then I got to figure out what my hypotenuse is. Okay, well, that's going to be negative 5 squared plus negative 12 squared equals my radius squared. So my radius is, let's see, that's 144 plus 25, so that's 169. You square root it, you get 13. Cool. So cosine is going to be adjacent over hypotenuse, so it will be negative 5/13. So now this is equaling, we're going to keep it positive, remember, square root of 1 minus cosine of theta, which is negative 5/13 all over 2. Okay, now we just need to clean this thing up. So I don't like that divide by 13, so I'm going to multiply top and bottom by 13. So this equals 13 plus 5 over 26. Still inside of a square root. So this equals the square root of 18 over the square root of 26. Yep. Now, one way I can see to simplify this thing just a touch is they both have a square root of 2 in there. You see that? That's the square root of 2 and the square root of 9 over the square root of 2 and the square root of 13. That'll cancel the two square roots of 2, so we get 3 over the square root of 13. Oh, and that's really easy to simplify. So it's 3 squared roots of 13 over 13. And we're set. And that's all for our half angles. Half angles, there are similar things that we've been doing with double and angle addition that we can do with half angles as well. But there's no reason to add that to our video. It's the same sort of rigmarole that we've been doing up to this point. A reminder, you hate yourself, don't do this one. If you're feeling frisky, this one is the best. When determining these pluses or minuses, make sure you're choosing that based on the location of theta over 2, not on the location of whatever this theta happens to be. Thank you so much for watching. We're through all of our identities for this chapter, and have a great rest of your day. Bye-bye.